Hello students, welcome and my best wishes to all of you for this class of module 1 part 5 of kinematics and theory of machine. Now over here, inversion of slider crank mechanism, we see that is single slider crank chain and double slider crank chain. So in single slider crank chain, the type 1 is crank and slotted lever quick return motion mechanism that we are going to observe over here. So in the given figure, in the left hand side, you see that there is a crank and there is a slotted lever, that is A to P, that is actually a slotted lever, and at point B there is a slider block, and C to B is the crank. Now the pin B slides along the slotted lever AP and makes the slotted lever oscillate about the pivot point A. A short link PQ transmits the motion from AP to the arm with respect to the tool along the line of the stroke. The line of the stroke is perpendicular to AC produces. But now what is the use or application of this particular mechanism? That is in shaping machine, slotted machines and IC engine, and this type of things that we can see. Now over here, particularly in the cutting tool or cutting machine, that is the shaping machine and all, there is a particular formula, that is time of cutting stroke divided by time of return stroke. The ratio of the angle alpha divided by beta is very much important, and the length of the stroke, that is how we can find out, that is the length of the stroke equal to 2 into A into P, that is the length of the lever multiplied by CV by AC. CV is nothing but the crank and AC is nothing but the length of the fixed link, which you can see over here. Now type 2 of the single slider is Whitworth quick return motion mechanism. Now in Whitworth quick return motion mechanism is a modification of the previous type of mechanism, obviously. Now here the link CD is fixed, the driving cam CA rotates about C, and the slider attached to the crank pin A slides along the slotted lever PA, which oscillates about the pivot D. The connecting rod PQ carries the ram at point Q with cutting tool. The ram reciprocates along the line of the stroke, and the application in shaping and slotting machine, obviously. And over here, time of the cutting stroke divided by time of the return stroke, that is equal to alpha by beta, and length of the stroke equal to 2 into P into T. Over here, P and D, P is nothing but a particular point which is connected to the connecting rod to the particular lever, slotted lever, and D is nothing but a pin. So the distance between P and D is very much crucial over here to find out the length of the stroke, because it is 2 into P into D. Now double slider crank mechanism, that is over here, that we can see, that is two sliders are present in this particular type of mechanism. In figure B you can see simply the simplified figure, that is two sliders, that is A and B, and one is the support, that is the supporting slots, or you can consider that is some kind of cylinder, and 2 and 4, these two are the slider blocks, and 3 is the connecting rod. So connecting chain consisting of 2 turning pairs and 2 sliding pairs called a double slider crank chain. Link 3 and 4 reciprocates, link 2 rotates, and link 1 is fixed. These two pairs of the same kind are adjacent. Now the inversions, if you are going to discuss about double slider mechanism, there are many, but today we are going to discuss upon only the first 4 types, that is donkey pump, Scotch-Yoke, Woldham's coupling, and elliptical trammel. So first the donkey pump, that is type 1 of double slider mechanism. You see that this is a figure. So over here cylinder is fixed, there is a piston rod, crank which is link number 2, slider which is link number 3, and there are guides. Now the link 2 or crank rotates about point A. One of the crank is connected to the piston through the piston rod, which reciprocates vertically in the pump cylinder. The cylinder together with the body of the pump represent the fixed link 1. The other end of the crank is connected to the slider or link 1, and the slider reciprocates horizontally in the cylinder. Next comes the Scotch-Yoke mechanism. In Scotch-Yoke mechanism, this is a very important type of mechanism where direct relation to the rotary and linear motion that we can see. Gives simple harmonic motion. It is early application was in steam pump. It is now used as a mechanism on a test machine to produce vibration. It is also used in a sine cosine generator for a computing elements. Now over here we see that x equal to r minus r cos theta, or r into 1 minus cos omega t. So velocity v equal to dx dt, that is r omega sine omega t, and a, that is acceleration, equal to d2x by dt squared, that is equal to r omega squared cos omega t. So this is the simple situation that we are going to get for simple harmonic motion. Next comes Oldham's coupling. Oldham's coupling are actually very common type of mechanism, especially in pumps, pump fitting, while the driving and the driven shafts are not coaxial but parallel, not collinear, but very much parallel type. So over here these particular types are used. The distance between whose axes are small and variable. The shaft connected by the coupling rotates at the same speed. An intermediate piece of circular shape and having tongs at right angles in opposite sides are fitted between the flanges of the two shafts in such a way that the tongs of the intermediate piece get fitted in the slots of the flange. The intermediate piece from link 4 which slide or reciprocates in link 1 and 2. Whereas link 2 is fixed, and maximum sliding speed of each tongue along the slot equal to distance between the axis of the shaft multiplied by the angular velocity of each shaft. Now comes the elliptical trammel. In elliptical trammel we see that there are two slots, two particular piston blocks, and one particular connecting rod. This particular device is used to draw ellipse. Two grooves are cut right angles in a plate which is fixed. The plate from a fixed link 4. Two sliding blocks are fitted into the grooves. The sliders form two sliding links 1 and 3. The links joining the slides from the link 2. Now any point on link 2 or on its extension traces out an ellipse in the fixed place when relative motion occurs. Definitely at any instant we are going to get capital X equal to BC cos theta, or cos theta equal to X by BC, or Y equal to AC sin theta, or sin theta equal to Y by AC. Now squaring and adding, we are going to get X squared by BC squared plus Y squared by AC squared. Definitely this is going to give us the result that is equal to 1, which is the equation of an ellipse. So that's all for today's session. Hope you like this particular video, and I'm going to return back very soon with new videos which will be helpful for you. Thank you very much.